All right, today we're going to talk about the letter E. E is not a variable. It represents a number. So E is an irrational number with an approximate value of 2.71828, an irrational number like pi. So E is not a normal variable. E actually represents a number when you see it. Okay, so you're going to need to remember that. E often occurs as the base of an exponential and logarithmic function that defines real-world scenarios. So if you want to find this on your calculator, it's right above the division button. If you have a TI-84 or 83, you have to hit second and divide, and you can punch that in and see the 2.71828, and it'll continue until it goes off the screen because it is an irrational number. So it's going to continue without repeating. All right, exponential functions with base E are called a natural base. An example, f of x equals e to the x power. And again, remember the e is the 2.71, so you have a number raised to the x power. Since the variable is the x, that makes it an exponential function. All right, base E. Logarithmic functions with base E are called natural logarithms. An example is you can go from log base E of x, and it can be abbreviated as ln x. It's still called log of x, but you don't have to write the base. So two things you need to remember. Okay, if you want to jot this down somewhere, maybe you already have it, but if you don't, if you just see log something, that's the same thing as base 10. And if you see ln of x, that's the same thing as log base E of x. So two things are assumed. We always have things that are assumed in math. If there's no exponent, you assume it to be a 1. If there's no coefficient, you assume it to be a 1. If you have a square root symbol and there's no index, you assume that to be a square root. So the index would be a 2. Those are things that are assumed in math. So now there's something else that's going to be assumed. If you have ln, you assume it to be base E. All right, so we're going to quickly look at some examples here. This is very similar to other logarithms, so it's not a lot of different things to learn. It's just a new abbreviation and perhaps a new number represented as the letter E. All right, so write an equation in logarithmic form. Very much the same. If you've forgotten this, go back to one of the other lessons where it says to rewrite a logarithmic as an exponent or an exponent as a logarithm. So here we're going to go in logarithmic form. Okay, so E is your base. So log base E, so it's going to be base E to the 24 equals x. So log base E of 24 equals x. Again, anytime you have base E, you can shorthand that to ln. 24 equals x. So this is still log base E of 24 equals x. The ln just represents that it's going to be base E. All right, so number 2, log base E of x equals 9. Again, your E becomes your base of x equals the exponent, which is 9. So again, this is very similar to what you learned with the other logarithms before. So this one would be log base E of 72 equals x plus 5. Again, we can write that as ln 72 equals x plus 5. So that's the same thing as base E. Going the other direction, we want to write in exponential form. So that means the base, even though there's no base there, you can assume it to be E. You can see this E has been written in here. So there was no base, but we know that's base E. So it's going to be E to the 58th power equals x. And remember, that's 2.7 71 something other raised to the 58th power. So that's going to be a really large number there. Here, exponential form, e to the x power equals 6. Again, we're just rewriting. E to the 32nd power equals x minus 9. All right, if we want to condense, again, very similar to what we did before. So you're going to look at your properties of exponents if you have forgotten. Addition changes to multiplication. Subtraction changes to division. And if it has a coefficient, it becomes a power. Okay? And a 1/3 actually can be written as cube root as well. So, but remember those three properties are very important, and that's what you're going to do here. So we're going to write this as a single logarithm. That means you're only going to represent the log one time. And then we're going to use the plus to multiply. And we're going to say log of 3 times 16 and then just multiply the 3 times 16 to get 48. Here, subtraction means division. So we're going to have log of 63 divided by the coefficient becomes the power. So it's 3 squared on the bottom. 63 divided by 9 is just log of 7. Okay, these should be familiar because we already learned the properties before. All right, so this is log of 64 to the 1/3 power, or the cube root of 64, and then times, because that's addition, x squared. So log of 4, because the cube root of 64, or 64 to the 1/3 power is 4, times x squared. To expand, we're using the same properties, but we're going the other direction. So since we've got 5 times x, we're going to change that to addition and put log with both of them. We assume that this is the base e. We're using ln to represent anything with base e. Remember, log is base 10, or it has a base. ln always is base e. All right, this property has division. That means we're going to subtract. Powers get multiplied, and the powers go to the front. So first thing we're going to do is say 3 squared is 6, and then b squared is on the bottom. The coefficient comes to the front, and then we expand by saying 6 log of a. Division becomes subtraction, 2 log of b. Here, cube root is the same thing as a 1/3 power. If it already has a power, that index goes on the bottom. So it'd be 2/3 for m, and then 1/3 for n. And then to expand it, we bring the 2/3 out as a coefficient, log of m. The multiplication becomes addition, and then the 1/3 log of n, just like what we did in the previous lesson. All right, I know we're going kind of quickly, but I feel like this is just a quick review with only adding the e to the scenario. So I don't want to spend a ton of your time here, so you can work on the lesson and get started. All right, so here we have the same base. We can cancel the logarithms or divide out by the logarithms and say we have 4x minus 27 equals 15 minus 2x. So we're going to subtract 15 from both sides or add 27, whatever you want to do. But we're going to add 2x. We're going to get our variable on one side, and just like solving a normal equation. And then divide by 6. X is 7. Okay? Here, you're going to look at your properties first. We have to condense this a little bit before you can solve. So the 2 is a coefficient. It becomes a power using your properties of logarithms. And then it's k squared equals 2k plus 15. And that's because they're both sides are ln, which means base e. So then we set this equal to 0. This is a quadratic. When you have a quadratic, you either factor, use quadratic formula, or completing the square. And then we're going to set it equal to 0. This one can be factored. So k squared minus 2k minus 15. 15 is 5 and 3. We need a negative 2, so that becomes the bigger number is negative. And then we set each factor equal to 0 and solve. Okay? When we do that, you have to plug it in to see if you have an extraneous solution. We talked about extraneous solutions with rational equations and with radical equations as well. And now you're going to see them again here with some of the logarithmic equations. If you take -3 and plug it in, you're going to see that it does not satisfy that equation. So always check your answers, plug in both. You plug in 5, you should see that that works. If you plug in -3, it's probably either going to not be true or it's going to say a non-real solution. All right, number 15, properties of exponents. Okay, we have subtraction, so this is going to become division, 72 divided by 4. You have to condense before you can solve. This is addition, so this becomes multiplication, 6 times a minus 2. So you're going to distribute the 6 and then solve. So add 12, divide by 6, and you're going to get 5. Again, plug it in. You should see that this one satisfies that equation, so it works. All right, 16, again, you've got multiplication. It becomes a power because the coefficient out front becomes the power of the problem. So you got m plus 4 squared equals 4. You have to multiply a binomial by itself when you have a binomial squared. So this is m plus 4 times m plus 4. That's where this line here comes from, equals 4. Subtract the 4 to set it equal to 0 so you can factor. Again, quadratic equations, we went through those again with polynomials. You learned quadratics last year in Math 2. So if you need to practice this, go ahead, but this should be just a review as well. All right, once you have your two factors, set them equal to 0 and solve. M plus 6 equals 0 becomes -6. M plus 2 set equal to 0. You subtract 2 and get -2. Those are your two solutions. When you plug these in, you're going to see that -6 is an extraneous solution. -2 is going to be a solution. All right, moving down to number 17 here. Log of 8x equals 2. This is your natural log of 8x equals 2, so we know it's got a base e. Before you can solve this, you're going to have to rewrite it in exponential form. So it's going to be e squared equals 8x. So you're going to take your calculator and find out what e squared is. That's where that 7.3891 comes from. Remember, E is the button above the division sign on your calculator. So you have to push the blue second button and then divide, and that's E. And then hit the squared button, and that should give you this number, equals 8x. Then divide that by 8. It gives you this number here. Okay? Same thing over here. Properties of logs says subtraction goes to division. So log of e, log base e of x over 9 equals 7. So we're going to rewrite that as e to the 7th power equals x divided by 9. Type in e to the 7th, and then you're going to multiply both sides by 9 to get your answer. Here, this one's already set up, so you're just going to rewrite this one as a logarithm because you don't know what the power is that's going to give you 57. So you're going to rewrite this as log base e of 57. In your calculator, down the left-hand side, I think it's 3 buttons from the bottom, you're going to see the ln button. That is your base e. Ln is your natural logarithm. Ln of 57, and that's going to give you your answer. All right. On number 20, you've got to add 6 first, and then rewrite it as a logarithm. So you're going to do log of 30, and then you're going to subtract 3 from that answer, and that'll give you this answer here. All right, there's a few more examples on here. You can look through those and see if you have any questions. Just email me and let me know. But I hope this is helpful, and I'll talk to you later.